historical levels of CO2 in the atmosphere. Because there's a theory put forward that the 350, there's this website called 350.org, which proposes that 350 is kind of the safe level. Now, I've seen graphs that, and I'm not quite sure of the sources, but I've looked at a lot of stuff on the internet that suggests that the levels of CO2 were actually much higher, even in recent times before the end of the last, since the end of the last ice age.
That's a good question. The gentleman's saying that he's seen graphs where the present level's 380 parts per million, roughly, and he's seen graphs which show higher levels than that, even recently, since the last ice age, but certainly earlier in geological history. The answer is yes, but those higher spikes in what we call the Holocene time, which is the last 10,000 years, the warm interglacial period we live in, are determined largely from studies of ancient fossil plants and counting the number of breathing pores, called stomata, that they have on their leaves. They're very good studies, but some people don't believe them. So one should be cautious about that. I'm not saying that's wrong. It is certainly the case. There are papers that identify that. But it is certain, if you go further back in geological time, that carbon dioxide levels were as high as 15 times today's. 15 times. The first metazoan fossils, jellyfish and little crabby-like things and shrimps and worms, evolved about 650 million years ago. Indeed, Australia is the only country outside of Northern Europe, outside the Northern Hemisphere, that has a geological interval named of the geological timescale after Australian fossils. And it's the very first metazoan fossils that ever evolved, and it's called the Ediacaran period of time. It's about 650 million years ago, and it's based on fossils collected from the Flinders Ranges in South Australia. And that was only designated about 10 years ago, and it's viewed as a great feather in Australia's cap. That's just like our iron ore deposits. We didn't do anything to deserve them, but it's nice to have them. So the Ediacaran is interesting because that's the first metazoan fossils, and at that time there's every evidence that the seawater temperature was about the same as today and the atmospheric temperature was about the same as today, but atmospheric carbon dioxide was 12 times as high as today. The idea that more carbon dioxide in the atmosphere will cause dangerous global warming is not substantiated by the geological evidence.
You mentioned before, Bob, the effect of El Nino is driving the 1998 warming. Can you describe perhaps what the engine, the energy engine to drive that El Nino effect would be?
That's great, being asked a question that requires a new PhD thesis to answer it. The question was, can I explain what drives El Nino? And the answer is, El Nino is an internal cycle of the ocean atmosphere system with a periodicity of somewhere between 2 and 5 years, irregular. And there are research labs all over the world to try and discover the answer to the question you've just posed. Nobody can answer it. That is one of the reasons why El Nino is not predictable, even with the most powerful computer models. It's perhaps predictable a few months ahead because you can look for early warning signs, but in terms of a theoretical equation, which will tell you when the next El Nino is going to happen, we don't have it. However, what is associated with El Ninos is the upwelling of cold water on the eastern side of the Pacific Ocean. There's a zone of upwelling there. And if that upwelling gets greater, then we have a lot more cold water at the surface, and we go into the La Nina phase. And if the upwelling slows down, the warm water of the western Pacific sloshes back across, and that's when we have an El Nino. But the actual driving cause of the changes in the upwelling and related things are not known. I'll take one more and then I'm going to move on.
You referred to the warming since 1998, so the way you described it, presumably 1998 is the hottest year on record. But I'm just wondering if you perhaps might elaborate on some of the years since then in terms of if we went to look at the Weather Bureau's data.
Sure, because
and also another really important thing, you mentioned the issue about modelling and the complexities, and the effect of CO2 on climate on temperature is very important. But if you want to perhaps elaborate on the effect on the oceans, which is
sure.
As I understand.
I'll come to that next because I'm talking about the modelling next. But answering the first question, which was What about 1998 being the hottest year on record, and is that still true? Because we all read the Bureau of Meteorology in the paper this week saying this year is going to be the hottest ever. The answer to that question is yes, if by ever you mean 150 years, which is all we have thermometer measurements for. Now, the meteorologists, not me, meteorologists define climate as different from weather in the following way. And before I tell you what the way is, let me tell you how Mark Twain defined it. Very clever guy, Mark Twain. He said, climate is what you expect and weather is what you get. Think about it. That's a profoundly clever statement. There's one thing scientists hate is clever people that haven't got mathematical equations. Just make smart comments. So scientists don't like that, and the meteorologists of the world back in the 1950s got together and agreed that they would define climate, in the 1930s, they would define climate as different from weather by defining climate as 30 years of average weather at one spot. So we put a thermometer out here, we measure the temperature, annual temperature, for 30 years, we average those 30-year annual averages, and that's one climate data point for Sydney. 30 years. We have 150 years of thermometer records. Can anybody in their head do 30 into 150? Of course you can. 5. Right. So we actually have, in terms of measurements, 5 climate data points. If I look at one of my geological climate data sets, I have thousands of climate data points. You cannot begin to make any sensible statements about the hottest year ever on the basis of 5 climate data points, which is what the Bureau of Meteorology is doing. So it is the case, yes, 1998 is the hottest year of the last 150. This year may or may not surpass it. So what? It's certainly not the hottest of the last 2,000 years, and even more certainly not the hottest of the last 10, 20, 100,000 years out to millions of years. The globe has frequently been several degrees warmer than today in recent geological history. So there's nothing, that's why at the start of my list of points I make the point, there's nothing unusual about the warming in the late 20th century. Absolutely nothing. Right, I'll move on. So that was the science reality, and it's what has to govern the whole debate. And right away you should be thinking, well, hang on a moment, I walked in here with this understanding, and now this guy he's from North Queensland, can't believe a word he says, but anyway, this guy's telling me that the science basis is different. Yes, it is. And you need to think about it, because the science is the basis and must be the basis for the whole thing. So the second reality is what I call virtual reality of the computer models. As I've already said, they're very clever, complex mathematical models. There is no theory of climate in the sense there's a Newtonian theory of gravity. What that means is there's no equation or set of simple equations you can plug into a computer that will allow you to predict what the climate, let's say the temperature, is going to be like in 5 years, 10 years, 20 years' time. You all know from watching television weather forecasting. Weather forecasting is quite reliable out to 4 or 5 days and completely useless in any period beyond that. And yet, we have a government that is setting national climate policy on the presumption that climate models can predict the temperature 100 years ahead. That is so silly, I don't have polite words to describe it. But that is the state of, not just in Australia, it's all Western nations, that's the state of public policy on climate change. It's based on the belief that these models can predict climate in 100 years' time. And all the models, there's about 20 of them, do indeed say that in 2100 the temperature will be between 1.8 and 5.8, let's round that off, 2 degrees to 6 degrees warmer than today. And there's 20 models, and they're all published by the United Nations body, I'm going to mention again, the Intergovernmental Panel on Climate Change, which advises our government and other governments on this issue. Now, think about this for a moment. There's 20 models, they all show slightly different paths of warming. They have to, if one of them says 1.8, the other says 5.8, and the others are arranged in between. So, if one of those models is right, the other 19 are wrong. So what do the models do? They say, well, we don't know which is right. So what we'll do is we'll take an average of the models. So here we are, here's this predicted line in the middle of that band of projections, and that's the most likely warming we're going to get.